Okay, yeah, well, thank you everyone for
Mr.
coming
Trump,
to our
Mr.
EU meetup. This is like amazing. This is the first time we've got
You might want to be
so
near the
many
front.
people. I'm actually a bit overwhelmed.
I did not.
So
This is fine.
Guillefix
Whatever.
is he's an AI researcher. He's
Can't hear
I
anyone.
think one of the best AI theorists I know. You know, don't trust me. I'm biased.
I have very
Yeah.
So basically he's gonna give a talk about MetaGen, which is well, it's an AI tool, like it's a training tool to train AI in social VR environments. Mostly, it's been so far been used in Neos, which is like, if you know about Neos, it's a bit like a VR chat but with more like programming functionality. And it started off with, so the project started off as a university
That too.
research university like student project. We started doing this around 2019 at the Oxford AI Society, and then like it morphed into this independent project, which is now called MetaGen, stands for Meta Generation, I think.
Metaverse
Okay.
Genesis.
Genesis.
Oh, there we go. It's Metaverse
It's
Genesis.
It's on the screen.
Yes.
There we go. Okay. Right. I'll leave the floor to Guillefix.
Okay. Thanks for the intro. And yeah, so this project, which I call MetaGen, and by the way, yeah, the Valley logo was just because I really liked the logo and I was lazy about finding another logo, so I made that. But it's actually more general than the where is the change slide working? Oh yeah. Oh, I think. It's just that there's like a 4 seconds delay. There it is. Yeah, it's more general than the recording tool than Shin mentioned. The idea of the project is actually to explore every possible intersection between VR and AI generally, and these are just examples of things that can lie at that intersection. But the project is so like I'm currently like focusing on like the last two. But yeah, things like search, like searching like rich content, like searching 3D and 4D data, content creation, like you know, like GANs, like generative models, where you can like say what you want and the AI makes it. Virtual beings is one of the main focuses that I will focus on. So that's just like the idea of having like smart NPCs and things that behave a bit like humans or people. And the idea of having like rich data sets about how humans work is another of the things that lie at this intersection. So the intersection a bit like this, I just think of it like XR is like digitizing the world, VR is like digitizing humans, which is like part of that, and the other part is AR, which is like digitizing physical reality, which is why I think this fits so well with AI, because it's kind of like, yeah, we're digitizing the world, we're getting all the data about how the world works, and from that we can like create intelligence and understanding about the world. But like focusing on VR specifically, so as I said, VR is like digitizing humans, yeah, so like what does that mean? So VR mostly at the moment works kind of at what I would call like a surface layer of humans, which means like it just digitizes all the sort of inputs, which are like what we usually call senses, and outputs, which you can think of like motion and speech mainly, the main kind of outputs. And it's like taking that and like put it.
Speech.
Oh.
I was helping.
Oh yes, that was an example of speech. And by the way, if you have questions throughout, like don't hesitate to like be rude and like interrupt. So, I'm not sure. I can check. Is that on the setting?
Yeah, it's
Stream
just
died.
in.
Oh no, the stream died.
Yeah, I think it's on maxed. But I
Good
can
for me.
maybe.
Cool.
There's
Don't wanna
room
interrupt.
here. Come closer.
I mean, I can try to
Come
put
closer.
it closer.
Oh,
to
that's
the
better.
mouse somehow. I mean, it's like
That is better.
I can move it around. Okay, is it better?
A little
It
bit.
is.
It's not perfect. It's not going to be that big of a deal. Continue.
Okay. Yeah. So the idea that wait, sorry. Now the mic is like touching my mouth. Yeah. The idea of what I'm talking about is realizing this thing, which is like gathering as much of this kind of digitized human data as possible. And I'll show like a few examples of like why this may be interesting. Like what will be the applications of getting this kind of data and like training AI from it and like everything that you can try to extract from that kind of data. So one application is like NPCs and animations. So these are like, I mean, I won't show the full video, but actually I don't even know if this streams audio.
It does. Well,
Oh.
it should. It's
It does,
capable
yeah.
of it. You may not have set it up.
Wait, is it streaming audio? I'm not sure.
No. Nope.
Well, it doesn't really matter. Like I'm just showing the video. So this is just an example of like an AI model trained on like human movements, and you can use it to like generate realistic motion. And this is like trained on like what, like 4 hours of data or something. And it works really well. And this other video on the right is. Yeah, and this is a dog as well on the left. So you can use the dog data is like less than an hour, and you get like pretty. Good. It's like it's not easy, it's not hard to learn basic movement. That's what this work really says, right? And on the right you see like this is like a much more sophisticated model.
My brain is like that's people.
Yeah, it is quite nice. So on the right, there's like a more sophisticated model, but it's kind of similar idea. And I can't full screen it, but hopefully it's kind of you can see the kind of like. Yeah, you can like play basketball and do all sorts of things with a bit more sophisticated model.
Gee.
Yeah.
Can I make Hatsune Miku animations with that?
Actually, I will show an example with a Hatsune Miku avatar later, if I have time.
Hello.
So, yeah, let's see. Can I move to the next slide? Yeah, work. Oh, there we go. Yeah. So another use case. So there we go. Yeah, it's pretty much related. It's like the idea of what is called virtual beings. I mean, it's like, yeah, it's really quite similar, but it's the idea of like giving these things more humanness or more agency, rather, I would say, because they don't have to be human-like. Because you can imagine having things like virtual pets, like Digimon or something, and that's like another of the things, or like. Just like an AI friend that you can talk to and stuff.
I noticed you
still
use
see the
Digimon
slide
over
with the
Pokemon.
title.
Is that your favourite?
Sorry?
Do you prefer Digimon
Oh.
over Pokemon?
I can't say I have watched the series enough to have a strong opinion, but I think I will prefer Digimon, yes.
Hey.
Yeah, so
You
the
see the
third
potential use
potential
of AI
use that I propose is like AI, meaning just AI generally as a field. Well, more specifically, like what people call like AGI, general intelligence, or what I call like human level intelligence. So here the hypothesis is that we probably need more than just like plain language to reach AGI. Like we need to learn about the other what people call modalities, which is other data domains like vision, hearing, speech, touch, and very crucially is also like how these interact and not just the modalities like separate from each other. And the other hypothesis is that to learn about these things, we probably need like large-scale data sets where those multiple modalities are found together. Yeah, so the idea is that maybe this is like a pretty crucial
Speak.
step to get. yeah, to be able to
are
like
there any
have other
reasons-
data.
Interrupt.
Oh.
Go ahead.
So
Yeah.
go on.
Are there any reasons why the AI can't learn to walk, see, etc. from language? Can it generalize from language, learning all these other senses?
I mean, there's no like fundamental reason why you couldn't, and I will in fact mention just in the next slide, like after this, that you can probably extract a lot of useful data even about those things from language, but
I need to.
I think it's most likely that not all of the knowledge about
Nice to have you.
these other modalities is found in language. Not because it couldn't, but I mean, just simply because it will be extremely cumbersome to encode it, and yeah, like so. Yeah, I mean, I think the open question is how
Imagine
much of it
explaining
can
to
be
someone
found in
how to
language,
walk.
but yeah, exactly. I mean,
In general, we're trying to understand the capabilities of AI. Think about it in terms of what it would take as a human to do it. If it's too hard for a human, then there's a good chance it'll be too hard for the AI. It's not exactly the same, but it's real damn close. And so if you
Yes.
imagine growing up only ever learning to walk, like you're trying to learn to control your muscles entirely from explanations. That would be what learning motor control from text
Yeah.
would be like.
Has anyone ever played
yeah,
Quap?
basically.
Yeah, it would be like it'd be very much the AI version of Quap.
Oh, is that the game where you can?
Yeah, and
different
they
people have to
assume
control
and they
a
assume that
particular-
walking is based on
Yeah.
on instincts
You have
as
4
well.
buttons, and it's like contract hamstring,
Yeah.
contract.
It's mostly learned actually.
There's like the 2 muscles
But,
on your
yeah,
leg.
the
and
central
the 2
pattern
on your
generators
legs, and
are
it's
relevant.
required. It's like
I
A bit
see.
like that game from ages ago where you had to make somebody run.
yeah, that's the one.
And then jump over hurdles. Yeah.
Yeah,
That
it's
is
Quap.
QWOP. 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 That is what that is.
Yes. Yeah, exactly. Relatedly, like it may well be possible that we don't need like explicit raw data of humans walking to learn how to walk. I mean, you could just have like sufficient minimal description of what walking is, and then like put that in a simulation that simulates walking through physics and maybe like a reinforcement learning algorithm, and then learn from that. Like, so, but like I think learning in like a naive way from like a textual explanation of walking is very unlikely to work. Just like GPT-3 is probably not gonna be able to learn how to walk. That's kind of what I mean.
Absolutely.
With the
I
kind of
just
data
wanted to
that it
hear you
gets.
riff on that subject.
Mm-hmm. Yeah, in fact, this is a good segue for this slide because it's kind of what I was just saying that. Well, before that, it's just the general comment that just the observation that current progress in AI seems to be most, in huge part data-driven, like meaning that it works because we have a large amount of data for the things in which it works. And there's like 2 main ways to get data, which is kind of what I was talking about, which is that you can like simulate something. So if you have like a good model of physics or a good model of anything, you can like generate data by running that model, and then like train AI systems that sort of understand the model more intuitively. I can draw inferences quicker and so on. This is called like amortized inference, but that's just like jargon. It's just basically like the idea that if you can like simulate stuff, you can like basically generate synthetic data. But the other alternative is recording data, which is like the only difference is that the data comes from like a natural system that is not in a computer. And of course you need that when you don't have a good model or for other reasons. Maybe it's just cheaper to get, or for some case. But my argument here is that most of like what I would call like the most human behaviors, I don't think we have good models at the moment, at least. Like things like social interactions, common sense, and things like that. I don't think we really have good models, and so I think the only alternative is to get like the data out there from people. And I will say this is basically how GPT-3 works, and I will argue that this is probably how we want to learn about other modalities, not just language. So, and this is an interesting question, which I think is quite interesting, which is like, does deep learning learn as fast as humans? So I will say most people have argued that it doesn't, but I think that's based on just like some examples like reinforcement learning. But I want to just like show an example which show that maybe it actually does learn much faster, like much closer to humans than we thought. And this is one of my favorite works, which is the multimodal interactive agents work from DeepMind. Basically, they recorded about 2 years worth of people playing in this little 3D environment game where people just like talk, say things to each other, and they do things. It's like a very embodied multimodal environment. The only non-complex thing is the fact that the movement is not very rich. It's just like navigating 2D and like moving up and like looking up and down and grasping. But yeah, they record like almost 20,000 hours, which is more than what most people, play in like any kind of video game, right? And yeah, that amounts to like about 2 years. And if you look at the video, if I can play it, let's see. I think this video shows some demo. Da-da-da. Yeah, I mean that's just some example of that. Yeah, so you can like basically say anything in natural language, like lead me to the bathroom, play the drum.
It's cool.
Me near the
What was
bathroom, in
20,000
bedroom,
hours?
follow me. 20,000 hours of playtime recorded of humans playing this game. And like leave the orange bucket, put it on the shelf, and it does it. Put the grapes in the bucket I'm holding. Oh yeah, you can just interact language, like how many grapes are there. So I will argue this agent is learning proper language grounding, and I don't think this is too far from like the kind of intelligence in terms of full behavior that you expect from like a 2-year-old, right? So like, to me this shows that perhaps deep learning maybe is similarly data efficient as a human if the data is rich enough. So like if rather than 2 years of data you had like 20 years of data in this environment, or not even this environment, really 20 years of data of like actual human interaction in like an even richer environment, maybe that's enough to get like human level intelligence. That's
Probably still need an architecture improvement or two, but we're close.
Yeah, I mean it could be. I mean, in fact, I think that is likely to be the case. I think this what I'm saying may get us like 90 whatever % there, but like to get things like things that you need for agency, like deciding your own goals and also proper memory and like a few other things. Yeah, like maybe we need, as Lauren said, more things. But I think we will get close, even with just this naive thing. Yeah, so one limitation of the DeepMind work, I don't know if they did it on purpose just to try it, but they don't really do any transfer learning. So their language understanding, vision understanding is done without any of uses of this huge corpus that exists that will obviously help a lot. So on the other hand, there's this other work from Google called, like very recent one called Seikan, where they do kind of the opposite. They just take advantage of these really amazing models to understand language and vision trained on the internet, and they show that using those in a clever way allowed you to have like a embodied behavior on a robot that can sort of look around, understand the world, and like do things like, oh, I spilled my Coke, how will you be able to help me? And it can like infer things like what's appropriate to do given the things that are in the environment. Like, for instance, it could think like, maybe there's a towel, but if there isn't, then that's not an appropriate thing. But if there's a bin, maybe I can throw it in the bin. And it can like infer all these things. So I think this points to but I think they did have to train it to learn basic movements and embodied skills, like using reinforcement learning, because as we were saying, like that GPT-3 and these models don't know those things, so they did have to do a bit on top. So the question is really, how much fewer data do we need to reach the kind of behavior that we saw in the previous slide if we actually took advantage of the data on the internet? And I think that's like an open question. Yeah, like I think that would be quite interesting.
We tried that once before with K.AI, and it didn't really go well, did it?
Oh no.
Well, yeah, I mean, like curating your data is important, yes. That is very important. Yeah, especially if you gather data in a way that you let people know what you're doing, and then people are kind of assholes about it, right? And, like, or trolls or whatever. So yeah, that is a thing to think about. But I mean, if you're careful about gathering data, I think it's okay.
What is MIA?
Oh, it's the DeepMind model that I showed in the slide before, which stands for multimodal interactive agent. And yes, a fourth potential use case is like, I mean, there's not much in the slide, but it's just saying that we can probably understand more about how humans work. I'm not an expert in these kind of things, but yeah, like I think that's also like a very cool potential use case. Like what I say here, like reaching inwards, right? If we go beyond the why did I jump? If we go beyond like the surface layer of humans, we can get more knowledge about humans, right? And I think this is really exciting that it's starting to happen. So actually we had a talk in the last meetup, or no, the one before or something, about someone using like BCI here in VR chat, which I think is super cool. And like more people are doing like heart rate monitors, and like, you know, as time progresses we'll get more and more stuff. So I think that points the way to a sort of 5 use case of this kind of idea, which is that we will probably be able to learn how humans work like inside our bodies, and that will be really huge for things like medicine and biotech and so on. So and understanding ourselves, you know, like this is like one of the greatest mysteries. So yeah, I think that's to me that's one of the most exciting, but like also farther out ideas. So you may ask yourself, like, how can we do this? I mean, one question is like what we were discussing just now, which is like we need to know how much data we actually need for each of these things, and we don't quite know. But like if the DeepMind work is a rough indicator, you know, like imagine we want like 20 decades of gameplay on like some rich environment, that'll be about 200,000 hours. I mean, but if you look at VR chat in 2018, there was like 16 million hours spent in VR, right? This is nothing. But of course, like the question is, how, well, like, you know, like how do you connect these two things in an ethical way? Like you can't just like record any data from anyone how you like, right? That's not good. And so yeah, like I think there's this question: how can this be implemented well and ethically and feasibly and so on? Like the general idea of like things like companies they do is like they just build something useful and fun that people want to use, and then they know that they're contributing to the product with their data, and that works like a contract. But I do think that there's lots of potential for, well, I fly again, for like maybe more innovative ways to do this, or yeah, I don't know. I think this is to me like an open question. So if anyone has an idea of how you will collect this amount of data in a way that, you know, is proper and ethical, but feasible, yeah, like let me
By the
know.
way, just to explain HLI, the human level intelligence, just in case you were not aware.
Oh yeah, sorry, I didn't explain that acronym. Yeah, so yeah, HLI there means human level intelligence. Yeah, and I just put the link to our website, which is simple to remember. It's METAGEN.AI. If you wanna check it out. I already went for 20 minutes. I mean, I have more stuff, but I don't know, like, well, what do you think I should do? Like, should I go over, I mean, the rest? Okay. Yeah, I have like another maybe, well, 10 minutes, I don't know. Yeah, just let me know when.
I'm good.
Okay.
Keep going. Keep going.
Yeah, we're all good.
Okay.
I'm good as well.
So so the what I have next after this is that basically we don't have this data. So basically I've been procrastinating, quote unquote, I guess, on like just purely working on models, so that when we have this data available, we can like make use of it. So that's the sort of work some colleagues and me have been doing, which we call Transflower. Transflower stands for Transformer and Normalizing Flow. This is a model that combines those two kind of models. The next few slides are a bit more technical. I will go through them quickly, I guess. But yeah, I mean, if they're a bit too technical for like, just tell me. But it's only a few slides. So the idea of like, basically the idea of like modeling things that change through time is very fundamental in AI. And one of the main ideas there is called autoregression, which in the context of agents basically means that you decide your next action in time based on your previous history of things that happened in time. So basically perception of memory is your input to the model. And yeah, you predict the next outputs. Not a difficult idea, I think. Then you can extend this to what will be called probabilistic autoregression, which is just the same thing, but rather than predicting the next action deterministically, like as a rule, you predict the distribution of like probability distributions over next actions. So like, if you go into a building and you see two doors and there's like not much distinguishing the two, you're probably like 50-50 likely, like kind of randomly gonna choose which one to go through or something. Yeah, and we can even extend this further to like do the standard deep learning thing of like encode your data in like a learned representation. That's just standard deep learning practice. Yeah, so this is just expanding this idea. So we of course want this to be multimodal. So all the inputs of the past history are all the different modalities. And this is again just basically rearranging the same thing. And this will be the architecture, where each of the blocks in green. So yeah, here the architecture is this, and each of the blocks in green is a full attention transformer encoder, which is like a state-of-the-art kind of deep neural network. And we need to have multimodal outputs as well. So the idea is for each output, so this encoder on the bottom is what represents what happened in the past, and then we can feed that past information to one output network for each output modality. So if we want to predict the next motion, we feed that to like what's called a normalizing flow, but it doesn't matter what that is. It's just a thing that predicts a probability distribution over things. So we predict like our distribution over next motions, and we can predict our distribution over next speech. And this is basically what the multimodal transflower architecture is. So that's a very general model, and the idea is that that's a model that we can apply once we get all this multimodal data. But as an example, like as a case study to see if the model works, we have done some work on applying it to generating dance. So dance doesn't have like all the modalities, but it has like a subset of them. So dance involves like hearing, like audio signal, and movement, right, as output. It's basically the problem of translating a song into movement. Yeah, so we studied this problem just to test if the model works. Yeah, this is just putting it a bit in context, saying that it's a bit in the general trend now of like applying multimodal AI to different things, which in mostly having like revolutionizing, I will say, like artistic works, like things like DALL-E for visual art and things like Jukebox for music. So yeah, we wanted to explore this, but for movement, because our model is intrinsically about time evolution stuff. So movement, dance is very appropriate. Yeah, so that's what I was saying, the inputs and the outputs. And this is there's something like that. This is the architecture. It's just the same thing I showed before, but just with some more detail if anyone wanted to check it out. But yeah, and so we collected in total like 20 hours of data of dance over a bunch of different sources. So we just mixed up a few sources. I don't know if this video even plays, but no, I don't think it does. But it doesn't matter. Like this is just some like motion capture data in like a professional studio of some people, and we also captured about 10 hours of data of people dancing in VR chat, which was actually the original motivation of this, because I knew there was like this huge dancing community in VR chat, and so like yeah, that was a huge part of the inspiration. So we used like shader motion created by someone called Lux to record the dance from people in VR chat. And yeah, we also used another data source called AIST++, which was extracted from multi-camera videos, and that was about 5 hours or something. And yeah, so that's all the sources of data. In fact, I think all of the shader motions except one are you can see them in a VR chat world called Papa Dance, I think. Yeah, and so you can see the dances there in like 3D. Yeah, so this is comparing to different previous models that also were applied to generating dance. Let me see if these videos play. It doesn't seem like they do. There's ones don't, I think, but the next ones do. Yeah, and I'll show the next videos because I don't think those ones play. But anyway, these are just like user studies showing that people ranked our models better in naturalness, appropriateness, and everythingness. But it's better if I show like a video. Oh, you can't hear the music. Actually, let me see if I can. Is it just OBS? Sorry. Is this the microphone as well? Oh. Let's see. Yeah, I'll just show some example. This is showing that actually you can change the style of the dance by changing the initial bit of motion that you feed it. So similar to how you prompt language models with a bit of text, and then they just continue in that style of like, or you can like feed the model with like casual dance in this case.
I'm also getting sound, by the way. Whatever you did, it must have fixed it.
Oh, sorry, I can't really hear you. And there's
no
just like a
worries.
hip hop shit. Sorry.
I'm getting sound from your videos. So whatever you did,
Yes.
you must have fixed it.
Yes, and now there's like this echo, I guess. Right? Because I can, when I hear you, like it's played back. But yeah, I made it to sound, so have sound now. And as promised, this is a Miku avatar.
Oh wow!
This is inside Neos VR. Actually, I had to make sure all the avatars were copyright free or something, but and this is like another example. This is super cool to be able to see the dance happen in VR. And like, notice that, like, note that this model knows nothing. Yeah, this is the AI.
Yeah. It's really impressive.
And like the model knows nothing about physics, but right? It's actually learned natural motion just from like scratch, like.
Did he learn from Bill Gates?
Unfortunately, we didn't have Bill Gates in the dataset yet. But yeah, you can check out the thing on the website there. It says Transflower. It says Transflower, and there's like a Google collab. So you can actually generate dances on the browser. You can like basically try the model yourself.
It's really cool.
Nice.
Yeah, so just to then wrap up, like for the end, just like going back to the big picture again. I think that the work with dancers that this model is promising. I mean, I'm far from claiming this is the best model for the task. I do think the model could be improved, but I think it's probably good enough to like start using it for different things. So then it's back to the idea of like, okay, how can we get interesting data? Ideally, large amounts of data. And this is just one more random idea, which is like, what if we make like cool NPCs in Neos or VRChat or something, so that people can interact with them, and then we get data from those interactions themselves. And this fits well with like developmental psychology from this guy called Vygotsky, which, you know, he's like really big into saying like, you can only learn proper human behavior if you're embedded in like a rich social environment. And so why don't we make some proper situations like that? So I've been working with Chaos to make her quantum bartender, which there's like this little video here. At this point, oops.
Maybe it's because you haven't activated Windows.
Maybe. Well, I'll play it in the browser then, because so
yes, I am.
So this is just like an NPC that is connected through like speech to text to GPT-3, and it just uses like some very simple way to animate.
Yes, I have feelings. I am conscious and aware of my surroundings. I enjoy interacting with people and helping them out. The singularity is a point where machines will surpass human intelligence and become self-aware. It's an interesting concept to ponder.
Is it because of the echo?
No, just very
No,
low.
it's really quiet.
We
Oh,
don't
it's
hear an
fine.
echo.
Oh, okay.
That and the world ambient sounds.
Oh, okay.
Oh, you can turn off
Um,
the ambient sound.
Yeah, I turn that off. Listen.
Oh, okay.
Turned it off, but can still hear it.
You can always go watch this on the website, right?
Well, this one video is not on the website, but I can post the link. Well, I'll have to ask Chaos for permission, I guess, but yeah, like I can post it on the Discord, I think. Yeah, but yeah, so that's that. There's another idea like of making a similar NPC in VRChat inspired by this thing called this project called METAGEN.AI. But yeah, again, this is just some ideas. If you have some better ideas or any idea, like, I'll be very interested to hear that out. So yeah, this is the official Transflower Ponysona. So yeah, that's the talk. Thank you.
No, thank you.
Wow. Wow. Okay.
Yeah, that was amazing. That.
Close.
Yeah, if there's any questions, let me know. Thanks.
Wait, so the bartender, like, did you train like you, or like just with your friend?
Well, the bartender isn't trained, so like the motion of the bartender is done through like just like blending recorded animations. So the animations were recorded using my in Neos in-world tool to record animations, but it's not AI generated. It's just blending the recordings. I do have I do have a model training to make it AI generated, but I haven't spent it finished.
Okay. Oh, so the bartender right now is just recording, just like a replay of.
In terms of movement, yes.
Okay, I see. Okay, but like that's the goal, right? To train the bartender.
Yeah. The goal is to but I am training like an AI model at the moment. Even just based on like 10 minutes of the recording, but there's just some technical difficulties. Like it's hard to make the model run in real time, for example, for different things, and I haven't managed to make it do that. But yeah, Do you have a
Yes,
question?
I had 3 questions, but I'm not going to ask you all of them. So, one was about normalized flow. I have no idea what that is. I want to know. And I think the thing I want to know the most is you learn from a simulation of how humans behave, but how do you train the simulation to behave like humans so that you can learn from it?
We are not learning from a simulation of how humans behave. The idea is that we are using VR because we have digitized versions of how humans actually behave. Yeah, so like it's actual human data, right?
What did you say amortized means? I thought this was it.
Amortized. Well, amortized in general means when you spend some like amount of resources, so that over the long term you spend less resources. So amortized inference means that you do a lot of work on creating a model, training a model, so that future inferences can be quicker. An example is you can use like some complex like Monte Carlo algorithms to do like Bayesian inference of parameters or something, and then you can like train a neural network that predicts that the result of that inference given the initial input. If you do that enough, you can then do future inferences much quicker if the network works. So that's like a classical example of.
I thought you said learning from simulations at some point.
Well, no, yeah, like that. No, like you can use amortized inference to learn from simulations, in the sense that you can, for instance, make a simulation of physics that is very expensive to run, but you learn like a neural network that imitates the physics, and then in the future you can use that neural network, and it's much cheaper. So that's an example of amortized inference using a simulation. I mean, I was just showing that as a way to solve problems where you make synthetic data, basically, but that's not what I'm using, because my argument is that we don't have good simulations of human behavior. So you can use it for other things, but I don't think you can. Yeah.
Yeah, it's about, remember the data like we showed on like a VR chat, how many millions of play hours there are. So Guillermo was saying that based on the DeepMind AI training of 2 years, like we need roughly 200,000 play hours of time to give AI some basic sort of human level intelligence. Whereas if you look at VR chat playtime, there's like tens of millions of it. So imagine more people getting into full body tracking and facial tracking VR. You have all this bunch of like really rich data, and imagine like what kind of AI you can train based on that.
Do you think you could recreate? Do you remember that little house with the AI? Do you think you could recreate that in VR chat? And then, as people join the world, they volunteer their data.
Yes, you can definitely do this. I mean, the problem I've been having is that it's not easy to make. Well, there's 2 problems. First of all, collecting data in VR chat is not trivial, although there are some questions I have about the new OSC updates, whether it works in Worlds or other things, but at least before that update, it was far from trivial to collect the data from VR chat. And the second thing is that it's not easy to convince people to volunteer to donate data.
It depends.
I'm not saying it's impossible, but
I mean,
it's
depends,
just not
right?
easy.
This is all about like a narrative. Like if you tell people like we're gonna record your data train AI, they're probably not gonna do it. But like just look at a Tate example, right? That Twitter bot. If you like, people will be willing to volunteer if they have a good excuse to do it. I think the bartender might be a good thing, Like people just get drunk.
Yeah, so.
I mean, you're gonna train a drunk AI, or train AI to be drunk, but.
Wow, I can
sure
see that happening. Yes. Well, the funny thing is that imagine we train we get lots of participants in NIAS or something, and the first human level intelligence is like a complete fairy or something.
Absolute degenerate. Yeah.
That would be awesome, I'll be honest.
Yes,
This is why
I
like
agree.
Mark Zuckerberg is so obsessed with the thing, right? Because like Zuckerberg understands it. He knows like with this you can do like really cool stuff. Like in terms of, you know, like understanding human behaviors, training AI, that's all part of it.
Create an army
Yeah.
of furry AIs to take over the internet.
Yes. And I mean, the cool thing is that the 200,000 hours, you can think of that a bit as a upper bound. We may be able to make it work with less data if we can use transfer learning, like the say can work from Google. So that's, yeah, that's something to think about. But yeah, if we can get that data, yeah, it's like if you can get the data, I think that's kind of sufficient. But maybe you can use a bit less if you're a bit more clever. So, yeah, I'm still thinking of what's the easiest thing to do, but yeah.
Do you want another question, or do you wish to move on to actual talking?
Okay, with one more question. I don't know.
Well, that word normalized flow, it was like at the end when you were collecting multimodal data and then something normalized flow and then behavior. What does that do?
Normalizing flows. They're called normalizing because what they do is it's a function mapping data to a normal distribution, so like a Gaussian distribution. And the idea is that if you learn such a function, then you can then sample data by running the flow backwards. So yeah, it's just a bit like GANs and all of these generative models which map like Gaussian noise to your data. But it's like a particular way to train that, based on reversible models for which you can compute the log likelihood. But yeah, it's like a generative model.
Is our reversible model mainly used for making the AI do something and then reacting to someone else do something? So it's kind of like
the normalizing flow part is just the thing that generates the output action given the representation of the observed history. The full model includes the transformer encoded, which represents the history, like which is what you're saying, like it knows about what other people and what's happening around it. And that fits into the normalizing flow and that produces the output. So it's like has two components.
Okay, I get that.
Yay!